All right, we're going to begin chapter 1 of our textbook. We're starting with chapter 1, section 2, and this is going to be kind of a simple lesson, maybe probably one of the biggest things that you remember from Algebra 1. And we're going to solve linear equations in one variable. All right, so solving equations in one variable, right? Linear equations in one variable, you're just solving for whatever variable you have, right? So if it's an x, you're going to solve for x. There's some special cases that some of you maybe remember, which are all real numbers and no solution, right? So all real numbers is if you get a true statement, right? So meaning the left and right side are equal. And a no solution is you get a false statement, right? So the left and right side are not equal, all right? And this is always going to be when the variable cancels out. So I'm going to say that the variables cancel out, right? So anytime that happens, you're going to be left with one of these two cases, all right? But let's just go through these examples. Starting with this first page shouldn't look super difficult at all, all right? So looking at this first example, we're trying to solve for x here, all right? Now to solve for x, it's just reverse order of operations. Opposite of minus 6 is going to be a plus 6. And then you're left with 3x equals 6. And then the opposite of multiplication is division, so I'm going to divide by 3 on both sides. So then I get x equals 6 divided by 3, so x equals 2. Super, super easy, right? Hopefully this is something that we are pretty comfortable with already. All right, so same thing over here. Only difference is that now I have a variable on the left and the right side of the equation. Now the goal is to get the x on one side and the number on the other, right? So I'm going to move my x's from, or how do you say? I'm going to move this 3x from the right side to the left side. Now the opposite of a positive 3x is a negative 3x, so I'm going to subtract 3x on both sides. 5x minus 3x is going to get you a 2x, and so we're left with a 2x plus 4 equals negative 8. Opposite of a positive 4 is a negative 4, so I'm going to subtract 4 on both sides. And you're left with 2x equals negative 12. Opposite of multiplying by 2 is dividing by 2, so I'm going to divide both sides by 2, and I get x equals negative 6. All right, very simple. All right, now the next one, we can do the exact same thing. Let's get the x by itself. There's a couple ways that you could do it. I would subtract the 7 on both sides. All right, but doing that, we're not just left with an x, we're left with a negative x. So I get negative x equals 19 minus 7 is 12. You can either multiply or divide by negative 1. All right, so let's just say we divide. If we divide by negative 1, this negative and negative cancel out. And so I get x equals 12 divided by negative 1, which is negative 12. All right, another thing that you could do, some people don't like seeing the negative in the equation. So sometimes what they do is they'll add x on both sides, and then you'll get 7 equals 19 plus x, and then subtract 19 on both sides, and then I get negative 12 equals x, right? We get the exact same answer. It's just a personal preference. Sometimes I'll keep the x on the left side of the equation. Sometimes I'll move it. It does not make a difference at all. All right, so now let's try the same thing over here. I'm going to solve for x. There's a 7x plus 2, so I'm going to get rid of that 2 first. Subtract 2 on both sides. We get 7x equals 21. Divide by 7 on both sides, and I get x equals 21 divided by 7 is 3. All right, let's keep going. This next one, I have a variable on both sides of the equation. I'm going to get it on one side. So why don't we add 2x on both sides? So I get 7x plus 3 equals 6. And then I can subtract 3 on both sides. And then I get 7x equals 3. And then we have to divide by 7 on both sides. So then I get x equals 3 over 7. All right, you're not always going to get nice whole number integers as your answers, right? If you get a fraction, that's fine, as long as you followed, as long as you didn't break any rules of math, right? You would have gotten this answer. And that's perfectly fine, right? It's perfectly fine to have a fraction as your final answer. All right, so let's try the same thing over here. I'm going to get the 2x by itself, or that minus 2x, so I'm going to subtract 7 on both sides. And so I get a negative 2x equals 8. divide by -2, and I get x equals -4. All right, so hopefully nothing too crazy. Hopefully we're pretty comfortable with this. All right, so let's do some more. All right, this next one's pretty much the same as what we've been doing. So I'm gonna get the x on one side. I see it on both sides of the equal sign, so I'm just gonna subtract it, and it's gonna get us 2x minus 9 equals 7. And then I'm gonna add 9 on both sides, and so I get 2x equals 16. Divide by 2, and I get x equals 8. All right. This next one gets a little bit more complicated, but hopefully we kind of see what to do, right? If I have parentheses, that just means I'm going to take whatever's on the outside and I'm going to distribute it to whatever's on the inside, right? Only whatever's on the inside of this parentheses, right? So it's not going to go to this 4, all right? Same thing with this 3, it's on the outside of parentheses, so I'm going to take that 3 and distribute it to both terms in these parentheses. And so what we're left with is 6x minus 6 plus 4 equals 21x plus 3. All right, and I could do the same thing that we've been doing and try to get the x on one side, the number on the other. But before I do that, I do want to combine these like terms. So we're going to get a 6x minus 2 equals 21x plus 3. So now we can get our numbers to one side. So I'm going to add the 2 on both sides, and so I get 6x equals 21x plus 5. All right, and then I can subtract 21x on both sides. And then 6 minus 21 should get you a negative 15x equals 5. And then divide by negative 15. All right, and so I get x equals negative 5 over 15, but that can be simplified, right? 5 and 15 share a factor of 5, so that's going to become a 1 over 3. So then your answer is going to get you negative 1 over 3. All right, now we can do the exact same thing with the next one. All right, I see parentheses and I see a number in front of it. That means I'm going to take that number and distribute it to everything on the inside. All right, and I'm going to do that before combining anything else, right? So I want to make sure the left and right hand side are fully simplified. So I'm going to take that 4, distribute it to x plus 2. That's going to get me a 4x plus 8. Plus 8 minus 12 equals, and I can distribute that 5 to everything inside of those parentheses. That's going to get me a 5x minus 30, right? And then we can combine like terms. 8 minus 12 is going to get me a negative 4, so I get 4x minus 4 equals 5x minus 30. And now we can go ahead and get the x's to one side, the variables on the other. So I can add 4 on both sides, and we can subtract 5x. And then doing that, our 4's are going to cancel, and our 5x's are going to cancel. So I get 5x minus 5x is going to get me a negative x, and negative 30 plus 4 is going to get me a negative 26. All right, and then from here, if there's a negative in front of the x, you can either multiply or divide by -1. All right, now if I divide, let's say I divide both sides by -1, I get x equals positive 26 as the final answer. All right, so we've done plenty so far that are kind of similar to one another. In all of these, if you're ever unsure of if you did the work right or if you got the correct answer, you can always go back and check, right? So that's going to be, your check is going to be plug in x into the original equation. So if you wanted to be absolutely certain that you got the correct answer, maybe you're worried that you made a little mistake somewhere, you can take that 26 and plug it in there and there, right? And that's if you want to check, your work. You can always just double check what you did, make sure you did every step right, distributed where you need to distribute, all right? But that's one way to check your work, right? So hopefully these aren't crazy difficult as of yet. Hopefully this is all review from Algebra 1. All right, so let's do a couple more like it. 10 and 11 are pretty similar, all right? So I'll kind of quickly go through these. Again, if there's something on the outside of parentheses, I can distribute. And then if I see a negative, we had said that we can treat this like a -1, and that's just going to change the sign of everything on the inside of our parentheses. All right, so doing that, fully simplifying the left and the right-hand side of the equation, this is going to get us a 6x minus 12 equals 7 minus x minus 5. All right, so that 7 is not attached to this expression right here, and it's not attached to this negative. All right, so don't let little things like that confuse you, right? These problems are hopefully not too difficult, but it's little things like that that might trip some people up. You might distribute something that you shouldn't distribute, or maybe you just combine something that can't be combined, right? So just be careful with your work in these problems. All right, and now we can simplify the right-hand side a little more. We can combine like terms. 7 minus 5 is going to get you a 2. So I get 6x minus 12 equals a negative x plus 2. And I'm going to get the x to one side and the numbers on the other. So I'm going to add 12 to both sides, add x to both sides. And so what that leaves us with, 6x plus x is a 7x. 12 and negative 12 cancel, x and negative x cancel, and then 12 plus 2 is 14. All right, let me write this off to the side. I'm kind of running out of room. All right, so I get 7x equals 14. And then lastly, you just need to divide by 7. And 14 divided by 7 is going to get you 2. All right, so we get 2 as our answer. All right, the next one's very similar to it. Let's try the exact same thing. All right, so let's, hang on. Okay, let's distribute that 4 to everything in the parentheses. And again, that negative you can treat like a negative 1. And I'll just distribute that to everything in the parentheses. All right, and so we end up with negative 8x plus 4 equals, again, that 6 is not attached to that negative, so it's just going to be 6 minus 2x plus 4. All right, and then combine like terms over here. 6 plus 4 is going to get you 10. So I get a negative 8x plus 4 equals negative 2x plus 10. And then get your x's to one side, your numbers on the other. So I'm going to subtract 4 on both sides and add 2x on both sides. All right, so negative 8x plus 2x is going to get you a negative 6x equals 4 minus 4 cancels, negative 2x plus 2x cancels, and 10 minus 4 is 6. All right, again, I'll bring this over here, running out of room. So I get negative 6x equals 6. Divide both sides by negative 6. And so I get x equals 6 divided by negative 6 is negative 1. So we get negative 1 as our answer. All right, good. So I'm using the same video for honors and regular. If you're in my regular class, you can skip 12, and I believe in the next slide we'll skip a couple examples as well. All right, we'll deal with those problems in the next section, so 1.2b, when we solve rational equations. All right, either way, in either class, you're going to see these types of problems regardless. But yeah, if you're in honors, you can keep watching, but if you're in my regular, you can skip these for now. We'll cover these in the next section. All right, but let's keep going. All right, so I'll show you one way how to solve problems like these where you have fractions, right? So some people, when they see these linear equations, they think they're so easy, and then they come across something with a fraction, and then all of a sudden don't know what to do, right? So there's one way that you can solve these kinds of problems, but we're not going to do it every single time. I'll just show you that this is one case where we would do something like this, and it's when you have a fraction equal to a fraction. All right, in this kind of case, you would cross multiply. Right? And it looks like this is a problem where we could get it to be a fraction equal to another fraction. All right, so 1/5 times 2x plus 5, right? It's in parentheses, so it's the entire thing. We can treat this as a 2x plus 5 over 1, and I'm going to do the top with the top, bottom with the bottom. And 1 times 2x plus 5 is just 2x plus 5. 5 times 1 is 5, so I get 2x plus 5 over 5 equals x plus 2 over 3. All right. Now, from here, hopefully you guys kind of recall something like this. We can cross multiply. So I can take these 2 and multiply it with these two. Right, so cross multiplying. All right, so everything that I highlighted in orange would multiply with one another. So 3 times 2x plus 5 would go on one hand, or I'm sorry, one side of your equation. So it's going to be 3 times 2x plus 5. And then everything that I highlighted in green would go on the other side of the equation. So it's going to be 5 times x plus 2. All right, now this is a very simple equation. I'll show you a little bit more about why this works, right? Maybe we remember that from Algebra 1, but we don't remember exactly why it works, all right? So if I have 2x plus 5 over 5, the goal in getting rid of a fraction is to multiply by whatever the denominator is, right? So multiplying by 5 on this side would cancel out that 5 on the bottom, and I would just be left with this here. All right, but with equations, what you do on one side, you would have to do to the other. So I would multiply this side by 5 as well. All right, same exact thing over here. To get rid of this 3 on the bottom, I would have to multiply by 3 on this side, and that would cancel over here. All right, but again, what you do to one side, you have to do to the other. So I would get 3 times 2x plus 5 on one side, which is what we have, and then a 5 times x plus 2 on the other side, which is what we have. All right, but to avoid doing all that work, you can simply cross multiply anytime you have a fraction equal to another fraction. All right, now this is a simple equation that hopefully we can solve, right? This is similar to what we've been doing so far, right? So I can take that 3, distribute it, and we would get something like 6x plus 15. And then on the other side, I can distribute that 5, and I would get a 5x plus 10. All right, and then get the x on one side, so we can subtract 5x. All right, 5x minus 5x cancels. 6x minus 5x is just x. And then I can subtract 15 on the other side. 15 minus 15 cancels. 10 minus 15 is going to get you a negative 5. So I get x equal to negative 5 as this answer. All right, so looking at the next one, they get a little bit more complex. Again, if you're in regular, Algebra 2 regular, you can skip 13 and 14. We'll cover those in the next section, 1.2b. All right, but we're going to continue with 15, right? So if you're in regular, let me write it off to the side. Regular, we're going to start here. All right, so regular, skip that and that. Okay. So looking at 13, it's another kind of problem with fractions, right? This time I have multiple fractions. It's not as simple as a fraction equal to another fraction. So you can try to kind of get it as a fraction equal to another fraction, and you could say, okay, there's a common denominator between 3 and 2, and that's going to be 6, and then you can get everything under a denominator of 6. What's missing over here is a 2, so I can multiply this by 2 and this by 2, and then I would get 2 times 2x plus 4, plus I could also multiply this side by 3, right? Multiply by 3, multiply by 3, and then I would get plus 3, do the exact same thing on the other side with the 4 and the 3. I would have to get a common denominator of 12, right? But that's kind of a lot of work, right? So I'm going to erase all this, and we're not going to do that. You could do it that way. You could get everything under a denominator. I think this one would be 6, and this one would be 12 on the bottom, and then I would have a big expression over here, and then a not as big, but still an expression over here. And then you can cross multiply and get 12 times something and 6 times something, all right? But again, that's a lot of work. You get kind of big numbers out of it. There's something that we can do that will get rid of all of these fractions entirely, and we can multiply by a common denominator across every single thing that's on the bottom. So I have a 3, a 2, a 4, and a 3. So what I'm going to do is I'm going to multiply this entire equation by whatever the common denominator is. Now between 3, 2, 4, and 3, the common denominator between all 4 of these would be 12, right? Hopefully we can see why that's true, right? Because 3 goes into 12, 2 goes into 12, 4 goes into 12, 3 goes into 12. All right, they all go into 12, so 12 would be our common denominator. And so that 12, I can take that 12 and distribute it to every single term on the left and the right-hand side of my equation. All right, multiplying an entire equation by a number is going to get you the exact same equation. All right, so if I take that 12, distribute it everywhere, let's go one by one. Let's see what happens in this first fraction, this 2x plus 4 over 3. If I do 12 times 2x plus 4, what happens to 12 on top, 3 on the bottom? Right, it becomes a 4. So then I get a 4 times 2x plus 4. And I can do the exact same thing for all of these. If I distribute that 12 and I get 12 times 1 over 2, well, 12 and 2 are going to simplify into 6. So I get a plus 6x. I can do the same thing over here. I can distribute the 12 and I get 12 times 1 over 4. 12 divided by 4 is going to get you a 3. And so we end up with equals 3x. And then I can do the same thing over here. I could do 12 times 7 divided by 3. And then 12 and 3 are going to cancel. That's going to get you a 4 times 7, which is 28. So minus 28. All right. And now this eliminates the fraction altogether, right? So you're going to see that I'm going to do this kind of frequently every time we have multiple fractions in one singular problem, right? Because doing that, we just eliminated the fraction in one step. All right. So again, just to recap that, I'm going to take the least common denominator, in this case it's 12, and I'm going to distribute it to every single term on the left and the right-hand side. And doing that is going to eliminate the fraction altogether, right? After this step, you shouldn't be left with any more fractions, all right? So then we're left with something that looks very similar to what we've done thus far, right? So I'm going to take that 4, distribute it, and then I'm going to be left with an 8x plus 16 plus 6x, and this is going to equal 3x minus 28. All right, so I can combine like terms over here. 8x plus 6x is going to get you 14x. I'm going to bring that up there. 14x plus 16 equals 3x minus 28. All right, and then I can subtract 16 on both sides, and I can subtract 3x on both sides. All right, 14x minus 3x is going to get you 11x. 16 minus 16 cancels. 3x minus 3x cancels. And negative 28 minus 16 is going to get you a negative 44. And I can divide both sides by 11. And so I get x equals negative 44 divided by 11 is negative 4. And so we get that as our final answer. All right. So a lot of steps, maybe the beginning part of it was probably the hardest part of that problem. All right, but you're going to see when we do the same thing with the next example, hopefully it makes a little more sense. And then especially the next section that we do, 1.2b, hopefully is going to tie everything together. All right, so I'm going to do the same thing with the number 14, but keep in mind there is a decimal in here. We don't really want to deal with decimals. We kind of only want to deal with either all fractions or all decimals. All right, but in these kinds of problems, I don't really like to work with decimals. I prefer to change all of them to fractions. All right, so 0.25 is something that hopefully we know how that converts to a fraction. Right, 0.25 is the same as a 1 over 4. Right, 4 quarters in a dollar, right, 25 cents. All right, so 1/4 is the same as 0.25. So I'm going to rewrite this as 2 over 3x plus 1 over 4 equals x plus 2. All right. Now we can try to get everything under one single fraction and then cross multiply. But what I'm going to do is I'm going to do the exact same thing as I did in number 13. And I'm going to multiply the entire equation by a common denominator. All right. The only denominators I have here are the 3 and the 4. Right. X and 2 don't have any denominators, but that's fine. I'm still going to just do the common denominator between 3 and 4. And that's going to be 12. If I wanted to get these under one single fraction, I would try to get a denominator of 12. All right, so then when I distribute this 12 to everything, all right, 12 times 2 over 3, well, 12 over 3 is going to get you a 4, and then 4 times 2x is going to get you an 8x, all right? And then I can do the same thing over here. 12 times 1 over 4, 12 and 4 is going to get you a 3, so I get 8x plus 3. And then there's no denominators here, so I'm just going to distribute as normal. 12 times x and 12 times 2. So then I get equals 12x plus 24. And then I'm going to do what I always do in these kinds of problems, and I'm going to get the x to one side and the number on the other. Let me just rewrite it over here so that I have more room. So 8x plus 3 equals 12x plus 24. Okay, no, I realized, sorry guys, I made a mistake. There's a x with it. 1/4 x, right? Maybe you guys caught it, but should be 3x and 1/4 x. Okay, sorry about that, but the same steps though, right? So 8x plus 3x is going to get you 11x equals 12x plus 24. All right, and then you can subtract by 12x on both sides. And so I get a negative x equals 24 divided by -1, and I get x equals negative 24. All right. Okay, this next one is maybe not as difficult conceptually as the problems that we just did. But this one is one that's super easy to make a mistake on, just because there's a lot of parentheses, there's a lot of things that you have to do in a particular order, and if you do things out of order, you might make little silly mistakes, right? So just be super careful with this, right? If you see all of these parentheses, brackets, whatever, you're always going to go from the inside out, right? Our order of operations, PEMDAS, says you're going to do any sort of parentheses first. So any groupings, we're going to do first. All right, so let's look at what we have inside of our parentheses or inside of our brackets first. This is what I have underneath my my brackets, right? Inside of my brackets. So I'm going to want to simplify that first. So I'm still going to have that 4 on the outside, and let's simplify inside of the brackets. Right, so I take that negative sign on the inside, and I'm going to distribute it to each term inside of those parentheses in our brackets, right? Treat it like a -1. So I get a 2x minus 3 plus x plus 5. All right, that's all I did, which is try to simplify a little bit on the inside first, equals -7x minus 2. All right, and then do a little bit more simplification on the inside of our brackets. Again, order of operations, it's going to be a 4 times 2x plus x is going to get you a 3x. -3 plus 5 is going to get me a positive 2 equals -7x minus 2. And then from here, this looks like something that we've done several times already. So I'm going to take that 4, distribute it to everything on the inside. I get 4 times 3x is going to get you a 12x. 4 times 2 is going to get you 8 equals -7x minus 2. And then we just get our x's on one side, our numbers on the other. So I'm going to add 7x on both sides. And then -7x plus 7x cancel out. So I get 19x. I can subtract 8 on both sides. 8 minus 8 cancel equals -2 minus 8 is going to get you a -10. All right, so I get 19x equals -10. Divide by 19 on both sides. And I should get x equals -10 over 19. All right, so just be careful with signs and whatnot, right? Make sure you're doing things in the correct order, right? Don't forget your order of operations. All right, now this last page is going to be all on some special cases that you might see. All right, so they look the same as everything that we've been doing before, but let's actually try one and see what's going on here. All right, so let's try this first one. Again, as always, if you see a number on the outside of parentheses, you can distribute that. And so I end up with the -2x minus 8 plus 3x equals x minus 8. And then combine like terms over here, -2x plus 3x is going to get you an x minus 8. And so I get x minus 8 equals x minus 8. Now maybe some of you can see what's going on already, right? Maybe you notice, okay, the right-hand side is exactly the same as the left-hand side, but if you didn't recognize that, let's keep going. So why don't we try and subtract x on both sides, right? I'm going to get my x's to one side, my numbers on the other. So I'm going to add 8 on both sides, right? But when you do that, x minus x cancel, negative 8 plus 8 cancel, I'm left with a 0, equals x minus x cancel, negative 8 plus 8 also cancel. I get 0 equals 0. All right, when the variable disappears completely, you're going to ask yourself, is what you're left with a true statement? So ask yourself, does 0 equal 0? All right, and it does, right? If it is a true statement, then this is going to be all real solutions. All right, maybe you've seen all real numbers. All right, all real numbers is also fine. Or maybe you see infinite solutions. Infinite solutions is also a valid way to write this, right? So all real numbers, all real solutions, infinitely many solutions, infinite solutions. All these mean the same thing, right? And it just means that you have a true statement no matter what you plug into x, all right? So that's how you're going to handle a variable disappearing and you're left with a true statement. Let's try the same thing with the next one. I'm going to solve it as normal, take that 3, distribute it to everything on the inside of those parentheses, and we're going to get a 9x minus 3 equals 9x plus 7. I can add 3 on both sides, and then 3 minus 3 cancel out. 7 plus 3 is going to get you a 10. All right, and then I can get my x's to one side, but subtracting 9x on both sides, it's going to cancel out over here, but it's also going to cancel out over here. 9x minus 9x is going to get you a 0. We're left with a 0 equals 10. When the variable disappears, ask yourself, are you left with a true statement? All right, and you're not, right? 0 does not equal 10, so this is a false statement. So this would be no solution. All right, there's not a single number that when you plug it into x, you get a valid statement. All right, so this is going to be no solution, no such number exists, where 0 is going to equal 10. All right, so I'm going to try the same exact thing with these next two. All right, let's see what happens over here. Again, I can take that negative 6, distribute it to everything on these parentheses. Same thing with this negative 3, I can distribute it to everything over here. And so I'm going to get a negative 12x minus 6 minus 3x plus 12 equals negative 15x plus 1. All right, and then you can combine like terms. So negative 12x minus 3x is going to get you a negative 15x. And then negative 6 plus 12 is going to get you a plus 6. All right, and then we get that this equals negative 15x plus 1. All right, so maybe you see what's going on right now with the 15x's. All right, but let's just keep going. Let's pretend we're oblivious to that. All right, so let's get our numbers to one side, our variables on the other. I'm going to subtract 6, and then 6 minus 6 go away. 1 minus 6 is going to get you a negative 5. And then let's get our x's to the other side. So I'm going to add this 15x. All right, but when you do that, it cancels out over here. Negative 15x plus 15x is 0, and so is this one, right? Negative 15x plus 15x is also 0. So I get a 0 equals negative 5. There's no more x. All right, and is this a true statement? No, this is never a true statement. 0 is never equal to negative 5, so I'm going to write no solution. All right, there's not many ways to write this one. All right, I know that the infinitely many had a couple of different ways. There's not really any other way to write this. Just write no solution. All right, and then let's do one more. So you might see the fraction and you might want to try to do what we did in the previous page and try to get rid of that fraction altogether. Or another thing that you could do is notice, right? This is just a denominator of 2, 6x and 14. If I distribute 1/2 to these, all you're going to do is you're going to cut these numbers in half, right? So if I did 1/2 times 6, that's the same as 6x over 2, and that's going to get you a 3x. And this is the same as 14 over 2, and that's going to get you a 7. All right, so we actually didn't need to do much to to the entire equation to get rid of that fraction. All you have to do is distribute that 1/2. All right, so be wise with the steps that you choose to do, right? You don't always have to pick a kind of a complicated or different way to do it, right? That was enough for that one. All right, and then over here I can take that 2 on the outside, distribute it to everything on the inside. And so I get that this equals x plus 1 plus 2x plus 6. All right, and then let's combine like terms. Everything on the left-hand side is fine. So I get 3x plus 7. Nothing more we can do to that. And then I have an x plus 2x, which is going to get you a 3x. 1 plus 6. All right, it gets us a 7. And now maybe we can see what's going on already, right? We can notice something special. 3x plus 7 is the same as 3x plus 7. Maybe we didn't recognize that and we wanted to keep going. So I'm going to subtract 3x on both sides. And then subtract 7 on both sides. And then what happens over here is everything's going to cancel. I get 0. Everything cancels over here and I get 0. I get 0 equals 0. That is a true statement. So I'm going to get infinitely many solutions. Infinitely many solutions. All right, so that's a valid way to write it. You can also say all real numbers. All right, so either one of those are correct. All right, so those are some special cases that you might see. Hopefully this lesson started out pretty easy. There's some stuff that requires a little bit more work, but it's essentially the same idea for all of these problems. You're essentially just trying to solve for x, right? They get somewhat complicated, right? But same idea, same concepts across the entire board.